Hi team, so today we are on lesson 3. We're performing operations on polynomials. So big words, that just means we're adding, subtracting, multiplying, and dividing things. So enter an expression equivalent to this thing in the form a, x, and then y. So what they want is they want us to take this -1/2, the at, and multiply it times 12t to the third. Okay, so what that looks like is I'm going to multiply my numbers together, right? So -1/2 and 12, that's going to give me -6. I have my a's, there's just one a, so that's going to sit there. And then t to the power of, let's find out, t, and t to the third is 4 t's all together. So I have that one like that. This is my answer. The way that it matches this form is that a is just a number, x is my a's to the power of 1, we don't have to write the 1, and then y is my t's to the power of 4. So we see that in the same format there. You would type this onto your screen. All right, for number 2, it says multiply and combine like terms to determine the product of these polynomials. We see a function here. I see 2 things times 2 things. That means the box to me. So I'm going to do 2n minus 3 times 5n plus 6. 2 times 5 is 10, n squared, minus 15n, 12n, and -18. I see some things that can be combined, so I have 10n squared minus 3n minus 18. There's really no reason to freak out when they give you all these directions. What they mean is multiply, that's the box, and combine like terms, that's the yellow part here, to determine the product. That just means the answer of a multiplication problem. So we can get that one for sure. Sweet. So we see a very similar problem. Which expression is equivalent to that? I see 2 things being multiplied together. I'm going to use the box here. I've got 2x minus t and 3x plus 5. 2x times 3x is 6x squared. 3x times -t is -3, and x and t, they're not like terms, so we can't combine them or square them. And then we have 10x, and we have -5t. So what I have here is 6x squared minus 3xt plus 10x minus 5t. So I'm going to look to see what I've got here. This one doesn't have x squared in it, so I know that's wrong. This one doesn't have the xt in it, so I know that one's wrong. This one also doesn't account. I can't combine these and there's nothing I can combine here, so I know it's not that one. I'm going to check out this one. It has the 6x squared, that's good. It has the -5t, so this part and this part are accounted for. And then I see here the 10 is positive, the 3 is negative, there's a t in one of them, and I see that x. Yeah, all that means that they did here was -3xt plus 10x. They saw what was in common was the x, and they took it to the outside, and that left -3t plus 10, or in their case, they switched this around and wrote 10 minus 3t, and then they just put the x over here. No, not a big deal, so we know that D is our correct answer. All right. And then finally, we have one more little crazy one too. Also the box. I've got ax plus b, cx plus d. I know that this is going to make acx squared. So make bcx. This is going to make adx. And this is going to make bd. So I'm going to look for the ones that are accounted for here. So I see this one is right here, and also right here. I see that BD is a different color. BD is here, and I see BD here and BD here. And then just similar to the last question that we just did, where we had this process where we took it out, I can also see that this and this have an x in common, which is right here. And then they have an AD and a BC, AD plus BC. So it's really annoying that they write it like this, but that would be your answer. So you don't need to freak out. Nothing crazy is happening. It just means that we have this. If you want to multiply these back out, you can distribute these in. You would have a dx plus bcx, which is what I see here, plus my bd, which I already saw there, plus my acx squared, which is what I saw there. So we see that those are exactly the same. All right. We'll look at part A and part B here. It says a town council plans to build a public parking lot. I can assume this is the parking lot that they have drawn here. The outline below represents the proposed shape. So they have a funky shaped parking lot, but this is it. It says write an expression for the area. So area, I know, is the space inside that section there, in square feet of this proposed parking lot. Explain the reasoning you use to find this expression. So if I'm going to do this, I want to make sure that I break it into things that I know how to find the area of. Area of a rectangle is length times width. This isn't quite a rectangle, so I'm going to go ahead and chop it up this way. Right? And I know the distance here, and I need to know the distance here, right? Or I can find this distance over here. I know that this whole thing, I know that this whole thing from here all the way to there is 2x minus 5. And I know that this section of it, the orange section, is x minus 5. So if I take the whole thing, the 2x minus 5, and I subtract the orange part, x minus 5, that's going to give me what's left over, which for now I'll just call the green part here, right? So for the green part, I would have 2x minus x. Minus x would be just 1x, and negative 5 minus a negative 5. So this distributes in there. That's basically like plus. So negative 5 plus 5 is 0. So I know that this green part right here is actually just x. Okay, so if I'm going to figure out the green area, I would do x times 2x plus 15. And if I want to find out the orange area, this part up here, I would do x times x minus 5, like that. Once I find those two areas, I can add them together to make it happen. So I have x times 2x is 2x squared, plus x times 15 is 15x, plus x times x is x squared, x times negative 5 is negative 5x. When I put these together, let's involve these, that's 3x squared, and 15x minus 5x would be positive 10x. This would be my total area. It does ask me to explain the reasoning, and so when I explain the reasoning, I want to make sure that I'm both showing my work as well as talking about my work. So the goal would be that I'm talking about my work here. So essentially, I'm saying the first box, I could really just literally call these what they are. So if I label this one number 1, right, then I could say here the area of number 1 is here. Right? And then if I call this number 2, I can literally say this is the area of number 2, right? And that is good explanation. The other thing that I might want to do is over here on this section, might just say subtraction in order to find the side length of rectangle 1. So notice that when it says explain, it doesn't necessarily mean that you have to use whole sentences. It just means that you have to label your work. You can't just like randomly put it together. But we could say that this is your total area. You want to make sure it says in square feet. So we would want to write that the total area is 3x squared plus 10x square feet. That would be our final answer there. Okay? I know that was complicated, but let's see what we can do here. It says the town council has plans to double the area of the parking lot in a few years. They create 2 plans. The first one increases the length of the base by p yards. So that means that they're adding on this distance here by that distance. We can assume that these are the same distances, right? So up here, when we found out that this was x, we still know that this right here is just x, right? We know that if we chop it off, we have x minus 5 for this section, and then we also have x for that section. So that would be 2x minus 5 together. So it says write an expression in terms of x to represent the value of p, right? So they want to know how big that is and explain your reasoning. So remember, we're going to label it. So if we're going to double the area, right? So this is my explaining. We're going to double the area. We have the area from the beginning, which is 3x squared plus 10x, right? And we're going to double it. That means multiply times 2. All right, so multiplying times 2 means that we have 6x squared plus 20x, like that. And then we're going to take away the area that's not included. So see, we're like doubling this section here, but we're not really doubling that section there. All right, so I'm going to take away this section here. That orange section, remember, we calculated was here, x squared minus 5x. So this here, x squared minus 5x. So we're going to take away, subtract x squared minus 5x. So if I'm thinking about this here, this is my double area, turns into here. And then I'm going to take away the nub, or the extra. All right, so take that away. 6x squared minus the x squared is going to leave me with 5x squared. And then 20 is going to turn this into a plus sign. 20 plus 5 is 25x. So that is the area of the 2 long pieces. 2 long pieces together. So the width is x. Right? The width is x. And we know that all of this together is this area here. So if I take away, let's say we know that area is length times width, and we know that the width is x. So I'm just going to write x there. So I'm going to divide these by x, divide this by x. Essentially, we have 5x squared plus 25x divided by x. That's going to, I can factor out an x here, gives me 5x plus 25 over x. That cancels my x's here. We know that now this whole section here, oops, what do we have? Yep. This whole section here from here to here is 5x plus 25. And so then we can take away this part that's over here, and that leaves me with 3x plus 10. All right, so 3x plus 10. This section here must be 3x plus 10. Right. Let me know what you think.